Hello, my name is Ryan Vervecki and I'm the Manager of Principal Architects at Vertana. Today we are going to go over a short video on Q-depth profiling. The purpose of this video is to show you how to use Virtual Wisdom's reports and analytics to do a Q-depth profile and review the overall relationship to performance. The integrations we are using in this video are the switch integration, our fiber channel hardware integration, which is required for Q-depth visibility. The switch integration is required for entity discovery. The services reports we will use are Fiber Channel Host Latency Investigation, and the analytics we will use today is QSolver. What are QDepths? Storage array QDepth is the maximum number of SCSI exchanges that can be opened at any given time on a storage port. HBA QDepth is the setting on an individual host bus adapter, which specifies how many exchanges can be sent to a target or a LUN at one given time. Virtual Wisdom tracks HBA and storage ports QDepths with a metric known as pending exchanges. Some of the many questions that are asked around QDepths are, why are they a problem or why are they a concern? QDepths often are set higher than what is optimal for most environments. If you set a QDepth too high, this can cause storage ports to overrun or be congested. This can also lead to poor application performance and potential data corruption or loss of data. One common misunderstanding is that if you set QDepths higher, it will equate to better performance within the infrastructure, whereas in reality, increasing QDepths can lead to performance degradation if set too high. If QDepths are set too low, it could impair the HBA's performance or lead to overall underutilization of storage resources. This occurs because the network will be underutilized and because the storage subsystem will not be able to take advantage of its caching or algorithms to improve performance. QDepth settings in HBAs can be also used to throttle servers so that the most critical servers are allowed greater access to the necessary storage or network resources. If they are not set correctly, critical applications may have to wait for data while low priority tasks proceed instead. This can cause variable and erratic transaction latency or overall performance impacts. Managing QDepths is the best way to prevent or minimize the severity of heavy load times and impact to a SAN. We will now go into a Virtual Wisdom demonstration. Once in Virtual Wisdom, you will need to go to the Reports section to review the reports that contain the information around QDepth or max pending exchanges. The report that you'll want to use is going to be one of the latency reports. So I'll go and type in latency here to filter, and we're going to use this one. You'll actually see it in both, but we'll use it in the host latency investigation report. When you go into this particular report and you scroll down a little ways, you're going to see a section underneath this report right down here that is called HBA and storage port QDepth. You can do it by application or host. I have actually filtered this already to a particular host to look at for this example. Here's the time frame that I have set. And you can see during this time frame, here is HBA port by ITL max pending exchanges. The max that we ever see to get to is 32, so inherently we can tell that this is likely set to a QDepth of 32 on this particular host and the HBA ports related to this host. Alternatively, over here on the right-hand side, you're going to see storage ports and what their max pending exchanges read. So this particular storage port, which is on a VNX, on the A5 port, at this particular time frame, the max it hit during this window was a max of 90. But what we have over here is you can see right around 12 p.m. we see our max pending exchanges go up. It hits 32, so we know that this is likely host set at 32 QDepth. For the most part, it averages well below that, but it does have time frames where it gets a little bit busier and flat lines around 32. What you want to understand now is when this type of thing happens, is there a performance related event or is there not a performance related event? Is it causing the response times increase or is the response time staying consistent? At the top of this report, you're going to see the performance metrics that are going to allow you to get a view into that. So what you see here is read completion times and write completion times. From here, we know that event was right around 12, and we can see sporadic events, but we had a more consistent issue right around noon when we saw that that response time increase right here is when we saw the QDepths go up. But if I look to the right at the write latency one, it looks like it was probably more write IO related, and we saw a significant increase in the response times when the QDepth went up over here. we can see the response times jumped about 6 milliseconds when they were running down below 1 millisecond. Doesn't necessarily mean that the increased queue depth is causing these response time issues. You have to take into consideration other things like IO sizes, the workload and stuff like that. Is it read or write workload? If I go down a little bit further, you'll actually see some of that workload information to see what's going on, and I'll kind of show you that. You can see it's a little bit of read payload and a little bit of write payload, so it's a little bit of both. What we do notice though is it's a little bit more of a significant write IO size change. Obviously, larger block IO is going to take longer to process. And if you're putting more things in the queue at a higher queue depth, then you could have an impact to response times, and the IO size could be adding to that. So this is how you use the host latency report to go in and investigate what the queue depth possibly is at the host, what we're seeing the queues at, the storage ports and what their related queue depths are. And then from here, you can come up and see at the top of the report how to investigate if there's an impact to response times. What we're going to do now is go into an analytic called QSolver, which will allow you to take all the data that we see around the response times and what the queue depth is at during all of the exchanges that are completing, and see if there's a better way to possibly tune the queue on this particular host. So to do that, we're going to go over here to the analytics section. From within the analytics section, we're going to want to run the QSolver output, which is going to be underneath the workload infrastructure balancing. You can come down here and click Run New, or you can do New Analytic up in the top and Run New and pick QSolver from there. When you come into Run New, it's going to take you to the new screen, and we were looking at one of our Hyper-V hosts. So you want to make sure you set the date range. You want to set it to the host that you were looking at. This is the host that we were referencing, was the Hyper-V. And then when you say run, it's going to go out and look at all the IO or the exchanges that completed during this window, what the queue was at during that time frame for the queue depth for the particular host HBAs, and it's going to bucketize all of those response times based on what queue they were at, and it's going to give us a report that kind of shows us how to look at that data and make a more accurate assessment of how to adjust the queue depth if you need to adjust the queue depth. For sake of this video, I already kind of ran one of these, so I'm going to jump over here. I'm going to go under my output section, and I'm going to go to this QSolver example. And underneath here, you can see it was at Hyper-V host. I had picked the time frame. I just ran it for the last day. You're obviously going to want to run this for an extended period of time because you want to make sure you're capturing the weekly, the daily, the monthly workloads when properly sizing the queue, because that way you're making sure you're sizing it appropriately. Other things you want to take into consideration is making sure you understand the profile of this host before you run QSolver. You really need to know, is it a heavy read workload? Is it a heavy write workload server? Because you can size the queue accordingly based to read or write IO. When you run it, what it's going to give you is an example down below. It's going to come back and say, based on read, there's no changes. If I select write, it'll tell me if there was any changes to propose for writes. So from what I can tell, this appears to be a properly sized queue depth on this host. How you read this data is, if I'm looking at the read data, if this was a read intensive host, it's going to show me the average read array latency on the left. It's going to show me the inferred queue depths on the bottom. This is a queue depth of 0 to 2, queue depth of 2 to 4, all the way up to queue depth of 30 to 32. What it's going to do is, if we see IO in those buckets, it's going to give me a box and whisker chart that tells me what my 5th percentile is to my 95th percentile, what my median is, as well as my 25th and 75th percentile. And it's going to bucketize those to see where the response times sit. And with a queue of 32, you can see I have a pretty straight trajectory of what this looks like, and it's not really impacting from a read perspective. When I'm at 32, my median is still around 7.35. When I'm at 2, I'm still around 6.35. So not much of a deviation. So it's not really recommending me to make a change because we don't really see too much of a deviation in these particular response times. If I come down to my write queue depth versus response times, though, what you'll see on the left is write acknowledgement latency. So it's how long it's taken the array to acknowledge your request when I see exchanges in these particular queue depth buckets. And again, it's 0 to 2 queue depth all the way up to 30 to 32. And even within this range, if I start down here, my median's 0.35. If I come up here, my median's 0.45. So I know the majority of my IO right around the middle isn't very much different. But what I do start to see is what we like to call a waterfall, where I start to see it going up. If this particular host had potentially had a QDIP set higher to 32, I might have seen this continue to go up, and it might have made a recommendation to say, hey, when I see you go above this, your response times start to get higher in your median and your upper percentiles, so you might want to lower this QDIP down to 32. This is how you use this data. It may not always make a recommendation, but the data points are valid to help you understand where you see your IO falling, what they look like in each of the QDEPs versus the response time buckets, and then you can make a more accurate assessment of how you want to properly tune the QDEPs on this host, if you properly want to tune the QDEPs. Again, you want to make sure you understand the workload profile of this host. Is it more read intensive IO? Is it more write intensive IO? And then you want to size your queue appropriately based on those workload patterns. So in summary, we described what QDEP is and the potential impact on the environment. We used the host latency report to identify a host QDEP setting and storage port queues. We reviewed how to investigate QDEP's performance relationship, and we ran QSolver analytic to cover how to interpret the data. Additional items to consider when using QSolver: you need to take into consideration more than just queue settings alone when profiling a server. You need to review the IO profile, the number of IOs, the size of the IOs, etc. You need to make sure to understand the read to write IO profile and size the queue depth accordingly to those profiles. Understand buffer starvation and potential impacts to array side latency and queuing as part of your queue profiling. You need to design a proper backend architecture and storage port masking to avoid queue sprawl by providing access to more storage ports than is required. And keep the number of LUNs allocated in consideration as part of your QDEP changes. The more LUNs that you have, the higher number of things you'll be able to put into the queue. This ends our queue profiling video. I want to thank you for watching.